Welcome to the Introduction to Algebraic Geometry. Algebraic geometry explores the relationship between algebra and geometry through polynomial equations and geometric shapes. In this presentation, we will explore the fundamental concepts, real-world applications, and essential tools of algebraic geometry, providing you with a solid foundation in this fascinating field. Algebraic geometry is a field of mathematics that studies geometric objects defined by polynomial equations. It builds a bridge between algebra and geometry, where polynomial equations correspond to geometric shapes. On one side, we have algebra dealing with equations and abstract structures. On the other side, we have geometry concerned with shapes and spaces. Algebraic geometry provides the connection, allowing us to study geometric properties using algebraic techniques and vice versa. This interplay is fundamental to understanding both fields more deeply. Let's look at some basic polynomial equations. First, we have a linear equation which is represented as ax plus by plus c equals 0. Then we have a quadratic equation, represented as ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0. Now look at some simple examples. X plus y minus 1 equals 0, x squared plus y squared minus 4 equals 0, and y minus x squared equals 0. Geometric shapes can be created from equations. The equation x plus y minus 1 equals 0 creates a line. The equation x squared plus y squared equals 4 creates a circle. The equation y equals x squared creates a parabola. An ellipse can also be created from equations. Algebraic varieties are sets of points that satisfy polynomial equations. A variety, denoted as V, is the set of all points x1, x2 through xn such that f of x1, x2 through xn equals 0. Here are a few examples of dimension. A point has 0 dimension, a curve has 1 dimension, and a surface has 2 dimensions. Algebraic geometry has a wide array of real-world applications. One key application is in computer graphics, particularly in 3D modeling and rendering. Another important application is in cryptography, specifically in elliptic curve encryption. It is also used in robotics for path planning and motion control, in physics for quantum field theory, and in engineering for computer-aided design optimization. To delve deeper into algebraic geometry, here are some essential concepts and mathematical tools. Some essential concepts are ideals, which are collections of polynomials, Groebner bases, which are computational tools for ideals, and morphisms, which are maps between varieties. Important mathematical tools include commutative algebra, which provides the ring theory foundations, topology, specifically the Zariski topology, and linear algebra, involving vector spaces and matrices. In summary, polynomials define geometric shapes, algebra and geometry are interconnected, and there are wide applications in modern technology. Now that you have been introduced to the world of algebraic geometry, here are some next steps for you. First, study polynomial rings. Second, explore ideal theory. Third, practice with examples. Thank you for exploring algebraic geometry. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.